Hello children, welcome back, and now let us try to solve few numericals based on this pressure and thrust concepts. Here we go with worksheet number 1 of pressure. So moving to the first question children, with the increase in weight of the object, the pressure. So as we know that the pressure is defined as force upon area, and force acting on the surface is nothing but because of its own weight of the body. Hence this force is due to the weight of the body. It is given as mg upon A. Okay, so with the increase in weight, so as the weight increases, then what happens to the pressure? Pressure also increases. Why? Because pressure is directly proportional to force, and this force itself is nothing but its own weight of the body. Okay, so if weight of the body increases, pressure also increases. So with the increase in weight of an object, the pressure increases. So first option must be true. So what is the correct option? Increases. So let us move to the next question. With the increase in area of contact of an object, the pressure. So as they said that thrust remains same. So as we know that pressure is defined as thrust upon area. Pressure is defined as thrust upon area. So, but they have told that thrust remains same, so this remains constant. So, very clearly we can say that pressure is inversely proportional to area. So, if area of contact increases, the pressure must decreases because they both are inversely proportional. So, what they said, with the increase in area of contact of an object, the pressure decreases. So, where is the correct option? The correct option is here, that is decreases. Second option must be true. So let us now try to understand and solve third question. 1 Pascal is the pressure generated by, as I told you, Pascal is the SI unit of pressure, isn't it children? So we know that 1 Pascal is equals to 1 Newton per meter square. 1 Newton per meter square. Okay, because in SI unit pressure is measured in Newton per meter square or simply Pascal. So 1 Newton per meter square is equals to 1 Pascal. So it can also be written as 1 Newton upon 1 meter square. So 1 Newton is the force, whereas 1 meter square is the area. So 1 Pascal is the pressure generated by a force of 1 Newton on 1 meter square. So a force of 1 Newton on 1 meter square. It's nothing to do with kg or centimeter square. Centimeter is a CGS unit. So generally Pascal is the SI unit. So clearly this is in SI, CGS, SI, CGS. You should not define like that. Everything must be in the same unit. So Pascal is the SI unit. So let us take everything in SI unit only. So what is the correct option children? First option is true. So what is that? 1 Pascal is the amount of force of 1 Newton acting on one area of 1 meter square. So moving to the next one children. Question number 4. The SI unit of thrust is. So thrust is nothing but force. Okay, that normal force itself is called as thrust. So whatever be the units of force, the same will be the unit of thrust. So obviously as force is measured in newtons, thrust must also measured in Newton, and hence the correct option is option 2, Newton. Okay, Pascal is the SI unit of pressure, dyne is the CGS unit of force or thrust, but they are asking for SI, so SI means it should be Newton only. So now let us have a look at the fifth question children. 1 Pascal is equals to, just now we defined the value of 1 Pascal is how much children? 1 Pascal is equals to 1 Newton per meter square. So the correct option must be first option, that is 1 Newton per meter square. Okay, so moving ahead with the next question, 6th one children. pressure exerted by a body on the surface is equals to. So pressure, as we know that pressure is defined as the force upon area or thrust upon area. In options as they gave it as thrust, so let me write it as thrust upon area. So pressure exerted by a body on the surface is equals to thrust upon area. So where is thrust upon area? Thrust upon area is nothing but thrust divided up by area. So where is that correct? Thrust upon area is nothing but the second option. Okay. So shall we move to the 7th question, children? Here statement problems are given. Statement 1, it says that animals like camels walk easily on deserts as broad feet exerts less pressure on the sandy ground. This is what we have learned in the concept. Because of the wider feet or broader feet of a camel, it exerts less pressure on the sand. Whereas if you compare other animals like horse or donkey, they have a small area of crossing. The foot is small area of crossing, so they may exert large pressure. So of course camels can walk easily, very easily they can use because they exert less pressure. Okay, so of course the statement is true. Statement B says that foundations of high-rise building, tall buildings, high-rise building, foundations are made wider. What is the reason? So that it can exert less pressure. So foundations of high-rise buildings are kept very wide so that they do not sink under the extremely high pressure of the buildings. Of course, this is true. So these buildings, when their foundations are made wider, they exert less pressure and they do not sink easily inside the ground. Hence, both statements are true. So the only correct option is the first option, that is both statements are true. When the bottom is wider, exerts less pressure and they won't sink inside. That's it. Question number 8. 1 bar is equals to, I told you children, bar is another unit of pressure, and the relation between 1 bar and pascals is 10 power 5 pascals. So 1 bar is equals to 10 power 5 pascals, and the correct option here is option 2. So moving ahead with the 9th question, children. A rectangular iron block is kept over a table with different faces touching the table. So what is given? A table is given, something like this. On this table, a rectangular iron block is kept with different faces touching the. In different cases, the block exert same thrust and same pressure. Children, what is thrust? Thrust is nothing but force upon the force acting or the weight of the body on the surface. The weight of the body acting on the surface itself is called as your thrust. If you keep the block in this direction or any direction, something like this, either way you keep, the weight of the mass of the body remains same and gravity also remains same. So weight of the body in this position or the previous position, both are equal. When weight remains same, thrust also remains same. So thrust is always same. Thrust is always same. It will not change because thrust is directly depends upon the weight of the body. Mass is constant, G is constant, so thrust is constant. Whereas the same thing, if you talk about the pressure, what do you mean by pressure, children? Pressure is defined as a force upon area. So pressure is equals to force upon area, or in other words you can also say that thrust upon area. But just now as we have discussed that every case thrust remains same. It directly indicates the weight of the body. So thrust remains same. Then what about area? If you keep the block in this direction, then area of contacting surface will be large, this much area of contact will be there. So larger area indicates large pressure. True? But the same thing, if the block is kept in this position, then what do you observe? It has less area of contact, very small area of contact you observe. Only this much portion is contact. In this case, the area of cross section is reduced. Okay, sorry children, earlier. Yes. So when as pressure is inversely proportional to area, lesser the area of cross section, larger will be pressure. And larger the area of cross section in the previous case, lesser will be pressure, because they both are inversely proportional to each other. So a rectangular iron block is kept over a table with different surfaces touching the table. In different cases, the block exerts same thrust, but pressure will be changing. Area of contacting changes, accordingly pressure also changes. So larger area of contact, less pressure. Lesser area of contact, large pressure. So different pressure. So the correct option is same thrust and different pressure. So second option is true. Now let us have a look at the 10th question. So what is given, children? Pressure varies with force as. Pressure. What is the formula for pressure? Pressure is defined as the normal force upon area. Pressure is defined as normal force upon area. Or in simple words, P is equals to F upon A. But what is given? Area is same. So given that area of cross section remains same. So this implies that pressure is directly proportional to force. So pressure varies with force as. Is P proportional to F? P inversely proportional to F, F square or 1 by F square? No doubt it is F. P varies, second if F varies, P also varies directly. Okay. So now 11th question. Find the odd one out. So you have to identify the odd one. First one, it is given as density. Density means mass by volume and it is a scalar quantity. Okay. Now moving to the pressure. Pressure equals to force upon area. Pressure is also a scalar quantity. Thrust is a direct measure of weight of a body. So weight of a body or force acting on a force due to that its own weight itself is called as thrust. Force in downward direction is called as thrust. Since force is a vector quantity, thrust can also be a vector quantity. Volume. So volume is nothing but the dimensions of the body and it is simply a scalar quantity. So what we observed there, this is a scalar, here it is a scalar, thrust is a vector and volume is a scalar. So you are asked to find the odd man out. Which one is odd man out, children? Obviously thrust is a vector quantity, hence it is taken as odd one out. So now 12th question. Dynes per centimeter square is the unit of. Dynes is the unit of force in CGS system. Centimeter square is the unit of area in CGS system. So if you take the concept of pressure, pressure is defined as force upon area. Force, SI system it is measured in Newton, whereas in CGS system it is measured in dyne. Area in SI system measured in meter square, whereas in CGS system it is measured in centimeter square. So dyne per centimeter square is the unit of pressure. Dyne per centimeter square is the unit of pressure. Okay, but if you discuss about force, force in a CGS is only dynes but not dyne per centimeter square. Thrust is also equivalent to force, so this is also measured in CGS system as dyne. Whereas Newton is equals to weight of the body, weight is equals to a force due to that body that exert on the surface. So if force is measured in dyne, weight must also be measured in dyne. So, but pressure is measured in dyne per centimeter square. So, the only correct option is option 2. So, have a look at the 13th question, children. SI unit of pressure is. So, pressure, SI units. So, as we know that it is measured in pascals. Pressure in SI unit is measured in pascals. Newton is a unit for force. Kg per meter cube is density, mass by volume. Kg indicates mass and meter cube indicates volume. Mass by volume, density. Kg meter square, no specific thing. So, not valid. So, SI unit of pressure is only pascals. So, 14th question, children. 1 millibar is equal to a pressure of. Now, sounds. So, what it was asked is 1 millibar is how many pascals? First of all, we know that 1 bar is equals to 10 power 5 pascals, children. Say yes or no? As we know that 1 bar is equals to 10 power 5 pascal. 1 milli. So, milli means how many? Milli indicates 10 power minus 3. Milli means 10 power minus 3. Okay. So, 1 gram is 1000 milligrams. 1 gram is 1000 milligrams. So, 1 milligram is equals to 10 power minus 3 grams. So, you know this? Okay. Similarly, 1 meter is equals to 100 centimeters and 1 centimeter is equals to 10 millimeters. So, this is 100 and this is 10 millimeters. So, totally 10 power 1000 millimeters. So, 1 meter is equals to 1000 millimeters or 1 millimeter is equals to 10 power minus 3 meters. So, 1 gram is equals to 1000 milligram. 1 milligram, whenever you want to convert milligram into gram, you have to multiply with 10 power minus 3. Similarly, whenever you want to convert millimeters into meters, you have to multiply it 10 power minus 3 meter. Similarly, whenever you want to convert pascals into millibar into pascals, then it must be equals to 10 power minus 3 pascals. Sorry, 10 power minus 3 bar. 1 millibar is equals to 10 power minus 3 bar. Millibar to bar means 10 power minus 3 bar. Millimeters to meters means 10 power minus 3 meters. Milligrams to grams means 10 power minus 3 grams. So, similarly, millibars to bar means 10 power minus 3 bar. So, this can also be written as 10 power minus 3. The value of bar it can be written as 10 power 5 pascal. So, all together it is 10 power minus 3 and plus 5, it is taken as minus 3 plus 5 is 2. So, 10 power 2 pascal. So, 1 millibar is equals to 10 power 2 pascals. So, where is the correct option, children? 10 power 2 is nothing but 100. So, 100 pascal. Either 10 power 2 or 100 both means same, that is 100 pascals. So, like this you have to answer, children. This is a rough calculation just to make you understand I gave you. Okay. So, millibar you have to convert in pascals, as we know that 1 bar is, we know that it is 10 power 5 pascals and 1 millibar must be equals to 10 power minus 3 bars, but whereas 1 bar it can be replaced with 10 power 5 and simplified you will be getting it as 100 pascals. So, look at the next question, children. Question number 15. The pair of physical quantities having the same unit is. So, let us check one by one, children. What is the unit of thrust? SI unit will take. Thrust is measured in newtons. Pressure is measured in Newton per meter square or Pascal. Again, thrust measured in Newton, weight also measured in Newton. Force measured in Newton, pressure measured in Newton per meter square or Pascals. weight measured in Newton, pressure measured in Newton per meter square. So what you are asked to find out, pair of physical quantities having same unit. Here different, here same, different, different. So the only correct option is option 2, that is thrust and weight have the same unit, that is Newton. So look at the 16th question. Pressure varies with area as we know that pressure is equals to force upon area. If force remains constant, pressure is inversely proportional to area. P varies with respect to 1 by A, and hence the correct option is 1 by A. So here instead of pressure they gave it as thrust. So thrust upon area. So as thrust given as constant, so pressure is taken as inversely proportional to area. Okay. So now 17th question, children. The ratio of the CGS unit of pressure to that of the SI unit of pressure is. Okay children. So generally we know that pressure is defined as force upon area, normal force upon area. So you have to measure first of all the CGS units of the same pressure and again the SI units of same pressure, and then you have to take the ratio. First of all, let us discuss the CGS units of pressure. In CGS units of pressure is CGS units of force is measured in dyne. CGS unit of area is measured in centimeter square. So CGS, it is dyne per centimeter square, first case. Now again you have to find out for SI unit of pressure. SI unit of pressure is force is measured in Newton. Area is measured in meter square. So you have to take the ratios of the two. Taking the ratios, equation 1 upon 2 gives the CGS unit of pressure to the SI unit of pressure. So what is the CGS unit, children? It is defined as dyne per centimeter square whole upon. SI is Newton per meter square. Is that true? So this CGS is dyne per centimeter square, SI is Newton per meter square. So this gives, I'll keep dyne per centimeter square as it is, and now Newton. 1 Newton is how many dynes? It is 10 power 5 dynes. Always remember children, 1 Newton is equals to 10 power 5 dyne. Is that okay? So 1 Newton is equals to 10 power 5 dyne. So this can be written as 10 power 5 dyne whole upon meter square. Meter is nothing but 100 centimeters. Meter square means meter into meter. Okay, that is 100 centimeters into 100 centimeters. Meter square means meter into meter, that is 100 centimeters into 100 centimeters. Okay, so this can be written as dyne per centimeter square whole upon 10 power 5 by this 100 and 100, 10 power 4 dyne per centimeter square. So simplifying this further, we have dyne cancels, centimeter square cancels. Okay, then this will become 10 power 4 and 10 power 5, this will become 1 by 10. Okay, how much is that? 1 by 10 after simplifying 0. Why 1 by 10 children? Numerator nothing is there, so 1 you will be keeping. 10 power 5 upon 10 power 4, 4 zeros will get cancelled and you are left with 1 0, so this is 10. So that 10 I replace it here. 1 by 10 means 0.1, and hence the correct option is option 2, that is 0.1. I hope you understood. So first of all, find out the CGS unit of pressure in pressure, and then later find the SI unit of pressure. Take the ratios of the, divide the 2, convert properly and divide 2, you will be getting the value as 0.1. Okay. So now 18th question, The reverse of the ratio of SI unit of pressure, SI unit of thrust to the CGS unit of force. So let us have a look, children. SI unit of thrust. So how much is the SI unit of thrust? Thrust is nothing but the weight of a body acting on a given surface. So weight measured in Newton. So SI unit of thrust is Newton. And now we are asked to find the CGS unit of force. CGS unit of force. So force SI, it is measured in Newton, whereas in CGS it is measured in dynes. So now you want to find out the SI unit of thrust to the CGS unit of force. And this is equals to Newton per dyne. So instead of Newton, let me write it as the full form, Newton per dyne. So how much is 1 Newton? 1 Newton is 10 power 5 dyne upon, down it's already dyne is there. So simplifying further, dyne gets cancelled and you are left with 10 power 5. So the correct option must be option 4, that is 10 power 5. That's it. Okay. The ratio of SI unit of thrust to the CGS unit of force is taken as 10 power 5. So now look at the 19th question, children. The pressure exerted by a woman wearing shoes with pointed heels. The woman wears a shoes with a pointed heels. Something like this, pointed. Is dash, then what an elephant. So they are comparing the pointed shoe of a woman with a elephant with 1 foot can exert on the ground. So elephant leg you have to consider something like this. Okay. Okay. So this elephant exerts some pressure on the ground. This woman also exerts some pressure on the ground with a pointed heel. So which is having a larger pressure? Lesser the area of contact, larger will be the pressure, because pressure is inversely proportional to area of cross section. Pressure is inversely proportional to area of cross section. Okay. Please excuse me, I'm bad artist. So anyhow, so because of less surface area in contact, the pressure will be larger. Large surface area in contact, the pressure will be lesser. So this pressure exerted by the woman on the ground will be much greater as compared to the pressure exerted by the foot of an elephant on the ground. So the correct option is much greater as compared to the foot of the elephant. So second option must be true. So now look at the 20th question, children. Pressure exerted by a sharp needle. Pressure exerted by a sharp needle on the surface is compared, so it has to compare with the blunt needle. So what is that? Sharp needle means less area of contact. So sharp needle surface area, I'll write. Surface area of sharp needle is small as compared to the surface area of blunt needle. But as we know that pressure inversely proportional to area, so which is having lesser area? Sharp needle has less area, blunt needle has large area. So this indicates that since area is small, pressure of this must be greater than pressure of the sharp needle exerts pressure on the blunt needle. That's it. So pressure exerted by a sharp needle on a surface is more as compared to the pressure exerted by the blunt needle. So the correct option is option 1. So the first option is correct, more as compared to the blunt needle. Okay, children. So with this we have completed the worksheet number 1 numericals. And now let us move to the next exercise in the next class. Okay. Until then, take care. Thank you, children.